I first saw this probability interview question thanks to Presh from Mind Your Decisions. The solution he presented was designed to be as intuitive as possible so that it would appeal to a broad audience. But let's take an engineering look at this probability question. Probability is a big part of electrical engineering and computer engineering, so let's present a solution that you would find in a probability textbook, for example, during your engineering studies. On the morning of January 1, a hospital nursery has 3 boys and some unknown number of girls. That night, a woman gives birth to a child, and the child is placed in the nursery. On the following day, a statistician conducts a survey and selects a child at random from the nursery, including the newborn child from the previous day. The child is a boy. So what's the probability that the child born on the previous day was a boy? This is a typical example of conditional probability. So let's define events and see how we'd solve it in a rigorous way. Let X be the initial number of girls in the nursery. And let's define B1 as the event that the child born on January 1 was a boy. And let B2 denote the event that the randomly selected child on day 2 is a boy. Our target probability is B1 given B2. Now, conditional probability is the probability of the intersection divided by the probability of the condition. So let's find the numerator and denominator and then divide them to get our target probability. Starting with the numerator, we'll use Bayes' theorem to invert this intersection because the intersection is commutative. Of course, the intersection of B1 with B2 is the same as the intersection between B2 and B1. And now we'll use the conditional probability for this case, which is B2 given B1 times the probability of B1. And the reason we're doing this is because the probability of B1 in itself is very easy to find. Let's see what we have. The probability of B2 given B1 is the probability that we select a boy on day 2, given that the child born on day 1 was a boy. Well, in that case, we'll have a total of 4 boys, and the total number of children to select from would be X plus 4, because 4 boys in total, and the number of girls would still be X, multiplied by the probability of B1. Now, B1 is just 1/2, because on day 1, there is a 50% chance that the child born will be a boy, and a 50% chance that it'll be a girl. So doing this, we get 2 over X plus 4, and that's the numerator. To find the denominator, the probability of B2, we'll use the law of total probability. Selecting a boy on day 2 could either happen with the child born on day 1 being a boy, or with the child born on day 1 being a girl. So exhausting those 2 possible options, we'll have the sum of these 2 intersections. And we'll use the formula of conditional probability for each case. So we'll have the probability of B2 given B1 times the probability of B1 plus the probability of B2 given B1 complement times the probability of B1 complement. Now, the first product is the intersection we just found, B1 intersection B2. So that's the same solution, 4 over X plus 4 times 1/2. The second product is B2 given B1 complement times the probability of B1 complement. B1 complement is the probability that the child born on day 1 was a girl. So in that case, the product would be 3 over X plus 4, because the total number of boys would be 3, but the total number of girls would now be X plus 1. So the total number of children is also X plus 4, but the numerator is 3 this time. The probability of B1 complement is the probability that the child born on day 1 was a girl, and that's also 50%. So working this out, we get 7 over 2 times x plus 4. So that's the denominator. And we're now ready to divide them to find the target probability. We can see that the x plus 4 cancels out, and the solution ends up being 4 over 7, which is approximately 57.14%. So that's it. The probability that the child born on day 1 was a boy, given that the statistician selected a boy on day 2, is 4 over 7. And if you think about it, this result makes sense. It's logical for this probability to be a little bit more than 50%. Because if the statistician selected a boy on day 2, then it's more likely for the child that was born on day 1 to have been a boy.